Okay, hello, this is Dr. James, and today I'm going to do some testing with this pretty cool frequency generator. I think, what was it, like $100 or something like that. It goes up to 6 gigahertz, it does sweeping, down to what, 35 megahertz I think is the lower end of the output. It's got a clock output, which I guess you'd use to sync up with other instruments at 25 megahertz. And it has a sweep function. I test out all this stuff with some of my other equipment. I have tested with some power meters that I have that I did some videos on, and some spectrum analyzers and some dip meters up at the higher frequency, because I don't have really equipment to measure up that high. But if you like to get up into the gigahertz range, and here, see if we can get that device. Very cool, huh? And it seems to be pretty easy to use. Puts out, according to my estimates, around 5 milliwatts or so, depending on the frequency and the calibration of the equipment, which I did different video on. But that's my estimate, about 5 milliwatts, so a lot more powerful than the other signal generator that I did a video on. Anyway, very cool. Let's take a look at this guy. Okay, so it looks like it has finally arrived. Oh, it's almost open too. Well, let me get my razor blade here, and we'll see what this is. Okay. What does that say? Let me open this box. Okay, there we go. Ooh, could this be my 6 gigahertz signal generator? Oh yeah, I've been waiting for this to come. Oh, this is pretty cool. Oh, look at that. Oops. There we go. Okay, so it's got some kind of foam bag that it's in. Oh, there it is. Look at that. I love this electronics. Just 2 circuit boards with some kind of standoffs holding them apart. Ooh, is this a USB-C? Okay, so let's take a look at this. Okay, so here is our cable, and it's inside of a sealed bag, static protection bag. So they put the circuit, which has actually got components that could be static sensitive, inside of a non-static sensitive bag, but they put a cable, which has no sensitive components in it, inside of a static sensitive bag. Very interesting. Okay, anyway, probably just cheap way to, I guess you want to keep the components from being shocked or vibrated or whatever. Okay, so unfortunately, well, yeah, I don't have a USB-C portable power supply yet. Oh, you know, I could probably power this off of my, oh, this is cool though. I did this in one of my other videos. If you don't have a computer power supply, you might want to, these are pretty cool. I'm able to bring dead cell phones back to life and some other things. Just out of curiosity, that would make this guy portable. Okay, so I have my computer battery thing there. And let's just plug it in here. Okay. What's this thing? Well, I don't see a switch anyplace. Oh wait, there's an on-off switch right here. There it is, right there. Oh, here we go. Look at that. Very cool. what is this, point frequency, or I can do sweep frequency. Wow. Point settings. That's 25 megahertz. Reference clock. Sine or square wave. I don't know how you change that. Here's the amplitude. Okay, I don't know. Stop. Point, sweep. Okay, I think I'm going to have to fiddle with this. It's got a start frequency, a stop frequency, a step, settings. Okay, let me fiddle around with this guy a little bit. We can see maybe what's going on here. Okay, so here's our new signal generator, and that one I think goes up to about 6 gigahertz. I'll have to check that again. And here's my tiny SA spectrum analyzer, and it has a high frequency and a low frequency. I forget which is which, or how, I mean, I know which is which. I forget how low the high one goes. And it looks like there's a clock output maybe from this guy and an RF output. And I have a BNC male adapter. So we could just turn this guy on here. See if I can remember how to turn this guy on. Okay, there's the on switch. And this is a cool spectrum analyzer, and I think it's in the low range. So we're going to switch the mode. Now I did another video on this one, and so I do extensive testing on this. So this looks like it's 240 megahertz. You know what, let me just test on the low range, because this one's set to 35 megahertz right now. So we'll just turn it back to low. Okay, and there's our low range, because this was already set at 35 megahertz there. And let's see if we see a signal when we hook this guy up. Okay. Okay. Is there a signal there? I can't really see a signal. Okay, let me fiddle around with this for a second. Okay, so I think I figured out what the deal is. So right now, there's no RF output because it's on stop. Now if you push it on point, watch, I'm going to push point. Gotta push a little bit harder. Okay, so there. And it does have a peak, and it's claiming that it's at 35 megahertz. Looks like it has a whole bunch of other spectral noise up higher though, which is, so we'll go, oh, you know what? You know what I should have been doing? I should have been putting the output into the low. Let's redo that one, because it's supposed to pipe the low input into the low input here. So let me do that. So that's probably why it was funky there. ID10T error. There we go. For all you computer, I don't want to call you nerds, computer enthusiasts out there know what I'm talking about. ID10. Anyway, I'm a nerd too, so I can make fun of nerds because I'm one as well. Okay, so here we go. So let me... Okay, so... Come on, really? Okay, so let's see. We want to turn point on. Okay, there we go. So that looks better because we were running the input into the high and we were measuring on the low. so we weren't seeing anything but noise, basically. So it looks like we do see a signal at 35 megahertz. And let me just stop this. See, when I stop it, it goes away. And we'll go to frequency, and we'll back up. Let's do 100 megahertz. 100 megahertz. Okay, and I'll hit the point. And there we go. And does it say 100? It certainly does. And again, this low setting goes up to 350. So let's try a different frequency. That's right, you gotta stop it first, then you can hit the frequency. We'll go to 300. Oh, we gotta back up. This is kind of annoying. 300. Enter. Okay, and again we'll hit point. And there we go. It's measuring 300 megahertz with this peak over here. Okay, very cool. So now I'm going to switch the output of this guy into the high input, and we'll test it up to higher frequencies. We can test up to almost a gigahertz. And that says minus 2.3 dBm, which I'm not sure how accurate that power measurement is, but it might be pretty good. I'll have to test it against my Chinese power meter as well. Very cool, huh? Let me stop this. Okay. I'm going to switch it back into the high input. Okay, so there now. I have the RF output going into the high input. I didn't switch over to the high input setting internally. So I'm going to click on mode and say switch to high. Okay. I don't know why this thing doesn't go into focus sometimes. Okay, so anyway, there we go. We have our signal generator here, and the high input goes from, come on, 240 megahertz to 960 megahertz. Okay, so let's just, okay, so we got it at 300 megahertz. Let's just turn it back on. So we'll turn on the point. There we go. And it is complaining that we're putting too much power into it. It doesn't like that much power. And so let's stop this. And I believe that the Tiny SA had a level. Actually, I don't know if this is shoot. Let me turn that on. So that's an attenuator. I don't know if that's a real attenuator or a calculated one. Let's just turn on the point again, and we'll see if it's okay. So now it's saying it's more in range. So that is a real attenuator in the Tiny SA. It looks like there's some other spectral harmonic stuff that's showing up. But I think we are at 300 megahertz, and now it's 0.6 dBm. Lower than before. Remember, it was all red and it was going off scale. So now I think we're good. So let's go up to okay, let's stop it, and we will go up to frequency, back. We'll go up to 600. What the heck? 600 megahertz. Okay. And then we'll turn the point source back on. And there we go. Let's take a look here. 600 megahertz on the Tiny SA. See, peaks right there. And I'm going to go up to 900, so we'll test it up to almost a gigahertz. Stop. frequency. Okay. 900 megahertz. Okay, so almost a gigahertz. Yeah, there we go. So the peak is at 900 megahertz. Very cool, huh? Very cool. So anyway, so it looks like it's putting out power, and actually quite a bit of power, because I think this thing's, you know, I don't know how accurate the power measurement is on this, but I think it was saying 2 dBm, which is pretty good. 3 dBm would be like, what, 2 milliwatts? that's quite a bit of power coming out of this thing. So it's what, 1 dBm is 1 milliwatt, so it's over a milliwatt. That's pretty good power output. Okay, let me stop this. Okay. So that's about the limits of the tiny SA, so I'm going to have to put it on something else to measure up to higher frequencies. Okay, so here I have my Regal scope, which is 100 megahertz bandwidth. I have this signal generator set on 35 megahertz, and I have to use my external battery, and it looks like this is what our signal looks like. Okay. So, kind of almost a square wave. I might have to, let me try some different frequencies, and I'll see what's going on here. See if it becomes more sinusoidal at higher frequencies or something. I'm not sure what the lower frequency limit of this is supposed to be. I'll have to look it up. Okay. Okay, so I got the cursor set up. It looks like that is about 35 megahertz approximately. And so here is our description here. Just wanted to check, and it seems like the lower limit is about maybe 25, or that's the clock speed, 25 megahertz. I think it said 23.5 megahertz was the lower limit, right there, to 6 gigahertz. 23.5 megahertz to 6 gigahertz. So the lowest you should be able to go is about 23.5. So maybe we'll try that out and see if we can bring this down to the lowest limit. Okay. Okay, so it's frequency, and then see if I can see this. You gotta go back, all the way, and then it's 2, 3.5. Okay, does that look good? 23.5. Done. Okay. And we'll try clicking on the point. And there we go. See, it changed the frequency. I'll move the cursors around. And that looks like about 23.5. Okay, so just out of curiosity, we'll stop this. We'll go to frequency. We'll go back. Can we make it do 10? 1, 0, 10 megahertz. Enter. Oh, it does not like that. Okay, so it gives me an error. It says you cannot put it in that range. Okay. Let's try. Let's see. We'll add another 0 to that. Back. 0, 0, 100. Okay. So that's actually past the limit of the bandwidth of the scope. But it looks like we are seeing a signal there. It looks pretty kind of sinusoidal. Okay, 100 megahertz. Of course, the scopes will have some response up above their bandwidth, and I actually did the upgrade to upgrade the 50 megahertz to 100 megahertz bandwidth, so the scope should be actually at 100 megahertz bandwidth. And I never did a video on that, but that was quite a thing to do. I think they have some kind of, they make the same scope, but they just limit it in software so they can sell one for more expensive and one for cheaper. Very, very crafty of them, huh? Let's stop this. Let's go to, we'll try back, 200 megahertz, which is going to be considerably above the bandwidth of my scope. Okay, 200 megahertz, enter, and we'll go to point. Yeah, it looks like there is a signal there at 200 megahertz, and it's very small. Let me get the cursors. Okay. And you see right here, cursors are saying it's about 200 megahertz. Okay, and that looks pretty sinusoid. Now the sampling rate is actually, I believe on this one, gigahertz. Yeah, 1 gigahertz sampling rate. So we should be able to resolve, provided the analog bandwidth is high enough, we should be able to resolve higher frequencies in this. We could try maybe going to, oh, we gotta stop it first. Back. Okay, 300. Oops, I missed. Fat fingered that. 0, 1, 2, 3. It's hard to see through this camera. 300. Okay, so there's 300 megahertz. And we have it entered in there. And let's hit point. And so the amplitude is decreased even more. I might be able to bump this up a little bit. And there we go, about 300 megahertz. Actually, you know what? I wanted to check one other thing. Let's take this all the way back down to. We'll stop this, and we'll go to, because this is really not an accurate measurement of the amplitude. We should try to measure the amplitude just to make sure it makes sense. And this thing liked to start at about 35 megahertz. So let's put that back in there. And this is that's 1 volt per division, and it's almost 1.5 divisions. So it's about, well, not one and a third division maybe. So it's about 1.3 volts peak to peak at the 35 megahertz, and it's kind of a square wave there. So I have to do the calculations, but that might be comparable to a little bit over a milliwatt. Okay. Actually, yeah, we should probably go ahead and do that. We'll do the calculations and make sure the power makes sense. Okay, let's stop this. Okay, so we'll get out the calculator here, and we'll say, be a little bit conservative, 0.5 volts times 0.5 volts divided by 50 ohms, right? Because remember, it's a 50 ohm termination. And that is telling us that that is about 5 milliwatts. So I guess that's, remember, we're measuring something over a milliwatt, significantly over a milliwatt with our a tiny spectrum analyzer. So it could very well be as high as 5 milliwatts, which is pretty good power for this type of device. Okay, so I guess things are in the ballpark here. Very interesting. Okay, so now I have my new signal generator here, and I'm just going to check the power output on it against well, I bought this, this is a power meter I bought a while back, and I think it wants to see at most 0 dBm. I did some calibrations of this guy against some HP devices, and I talk about how good, you know, some frequency ranges it's got better performance than others. You know, some frequency ranges it's kind of off by a factor of 2 or so, but I mean it still gives you an indication. And indication of the power. And here's our guy over here, and like I said before, he's putting out too much power for this guy to see, so I put a 10 dB attenuator in here. And looks like I'm going to need a coupler also, because this is a female and that's female, so let me see if I can grab something. Okay, so here's a coupler, and I'll just put that guy in here. Okay. And after I do this, I will check to make sure it's actually generating frequencies up to 6 gigahertz. I'm going to just make sure it puts out power over the range first, though. Okay. So let me I have my USB-C cable plugged into the computer, and we'll turn this guy on. Oh, here. And this one I just have a real simple power supply. Just pull one of the batteries out, or power switch I should say. Okay, let's see, where's the switch on this guy? I remember it was someplace weird. I hit the switch someplace on this guy. Huh. Oh, it's right here. Okay, here is the switch for our signal generator. And, okay, so 540 microwatts. So I don't have the power on the output right now, so we will say, point. Okay. So it is telling me it is minus 4 dBm. Okay. Okay, watch that. I'm going to turn it back off. That's alright. Stop. Stop. Okay, and so now it's not minus 52 dBm. So it is putting out power at 38 megahertz at a level of minus 4 dBm. Okay. So let's just try. I'm going to just skip around to some frequency. I believe I have to turn this off to change the frequency. We will set this at 1. Oh, sorry, that's right, you got to back up on this guy. Back up, back up, back up. 1 gigahertz. Enter. Oh, it's got to be a megahertz. You got to be kidding me. Why would you have a gigahertz selection if you got to put the frequency in megahertz? That doesn't make any sense. Let's call this 1,000 megahertz is 1 gigahertz, right? Okay, and we're at minus 52 dBm, and let's hit the point. Okay, so minus 4.4 dBm. And remember, this is a 10 dB attenuator, so that would be around almost 5 milliwatts output. Oh, I'm sorry, minus 4 dBm plus 10 would be, I'm sorry, that wouldn't be 4, that would be, 14, that would be 10 minus 4 plus 6, about plus 6 dBm, right? if you add 10 to minus 4, that's a little bit less than that because it's 4.5. So a little bit less than 6 dBm, and remember 3 dBm is 2 milliwatts. Zero dBm is 1 milliwatt, and then you add 3 more. 3 dB is a factor of 2, so from 1 to 2, and then another 3 is, so it's between 2 and 6 milliwatts, probably closer to 6, maybe about 5 milliwatts. So that's a little bit less than plus 6 dBm, and so that'll be close to 5 milliwatts probably. Okay, so let's stop this guy, and remember this, I did do a calibration on this guy, and it's pretty good cal over some of the frequency range. I think in the gigahertz range it's not too bad. When it got up to some of the higher frequencies, its calibration was not so super great. Okay, so let's do 2,000 megahertz, so 2 gigahertz. Okay, and so minus 1 dBm. So minus 1 plus 10 is about plus 9, right? So that's 3, 3, 3. So factor of 3 is goes from 1 to 2, 2 to 4, 4. So it's close to 8 milliwatts if you believe the calibration of this, which I can't remember exactly what it was, but some places it wasn't too far off. Okay, let's stop this guy. So let's change the frequency again, and we will back up. 0, 1, 2, 3. 1, 2, 3. Okay, 3,000 megahertz, enter, or 3 gigahertz, and we'll put that on point again. Okay, so again we're putting out power in the minus 3 dB range, and remember we have a 10 dB attenuator in there, so you got to add 10 dB to that. Okay, so we're putting out power at 3 gigahertz, so this thing says, and I'm going to check the frequency to make sure the frequency is true later. Okay, we'll stop that, and we will back. Okay, 4, 1, 2, 3. Okay, enter, and again the power is off, minus 52, and we turn the power on, minus 7. So minus 7 plus 10, or minus 8, that's about plus 2 dBm. So plus 2 dBm is a little bit less than 2 milliwatts at 4 gigahertz. Okay, let's stop it. And we'll go back into point, and back. Okay, and here's 5, 2, 3. Oh, let me just, did I hit the wrong button? There we go. Okay, so that should be about 5 gigahertz. And again, we will turn the power back on here. And say is minus 11. Minus 11 plus 10 is minus 1 dBm. So a little bit less than 1 milliwatt at 5 gigahertz. If you can believe that calibration, which I can't remember. You have to watch my video, or I'll have to watch my video again to see how much the calibration was off at these frequencies. Okay. Okay, so we stopped it, and we will back up, and we'll do one final point at 6 gigahertz. 6, 1, 2, 3, 6 gigahertz. Okay, so there's 6 gigahertz, and again we'll turn the point source on, and it's saying about minus 15, minus 16 dBm. So plus 10 would be about minus 6 dBm, so that will be about 4 dB below a milliwatt. So half a milliwatt, quarter of a milliwatt maybe at this frequency. So a quarter of a milliwatt at 6 gigahertz. Okay. So, and again, the calibration on this guy did vary over frequencies. So some frequencies it wasn't super great cal, but I think it wasn't too bad. And it's really cheap, so you can't beat that. It's better than a diode or something, an RF diode. Okay, so here we go, 6 gigahertz. Very cool. Let's stop that. Okay, so next I'll check the frequencies on this guy and make sure it's putting out the proper frequencies, approximately. Okay, so let's test it at the high frequencies, and the only thing that I have to test at the high frequencies right now is I can test it against a dip meter, and this is a 1950s type mechanical device, and it has, let's take a closer look. So it has a bunch of numbers on it, and see if we can get that in the focus. And you can twiddle this knob up here. Let's see if they can in focus. Okay, so it's got a bunch of numbers, and then you read between these lines, and it has a resonant cavity in here. And when you tune this, it changes the resonant cavity, and they know they've measured what the resonant frequency is, and so you can. What happens is when you generate the right frequency here, it will have a dip on the diode over here. Okay, so let's check this guy out. Basically, the power will dip a little bit as you sweep through the resonance. Okay, so I'm going to turn the power on, so I'll click on point here, and you can see when I turn the power on, okay, so it goes from about 0 to 12 millivolts, and I'll twiddle this, I'll drop down the 9. Okay, I wonder why it does that. Anyway, let's twiddle this guy until we see a dip. Okay, see there's a dip there as I'm turning the knob up here. And it goes back up, so I'll turn it back. Okay, and let's take a look here. So 6 gigahertz is right about there. So I don't know if this old dip meter is just a little bit off, or if it's it's hard to measure this frequency any other way, but it is claiming to be at 6 gigahertz, and it's putting out power at that frequency. Gosh, I don't know if it's good. I don't know if that's in focus or not, but it is 6.0 gigahertz. For some reason, these things. There we go. Okay. And so our dip meter had a dip right about there. Maybe the power is unstable, or maybe it's a crystal detector is old, got a problem, because it looks like the power's back up again. Anyway, we'll turn off the power. You can see the power goes away on the crystal detector. And, okay, so it does look like it's putting out energy at high frequencies as well. Okay. And I guess the last thing I didn't test is a sweep function, so maybe I'll test that on my little spectrum analyzer. Should be interesting. Okay, so now I have my tiny spectrum analyzer hooked up to this guy over here, and I put a 10 dB attenuator in there because last time I was checking it, testing it with this guy, it was a little bit too high a power, and I'm going to change the mode here so I can do into the high input, so I can test the high frequency range. And okay, so it's about 240 to 960. So I think what I'll do is I'm going to set up our sweep here, and so we'll do start frequency. I guess I'll click on start. That's why I gotta have it in stop mode. So start frequency, and again we'll do this thing where we gotta do the backspace, and it's in megahertz, so we'll say 240 megahertz for the low end, and for the stop frequency we will do, remember we can only measure up to about 960, so back 960, enter. Okay, and I'll just leave it at 1 megahertz step, and I will click on sweep. Okay, let me get over here and take a look at this. Okay. Okay, so it looks like it is sweeping through the frequencies, and the spectrum analyzer is catching it at various points. Okay, and it's going to start its sweep again. Looks like it is, even with the 10 dB attenuator in there, it is higher than what it wants to see. Let's see. Okay, I think it's under level attenuation. I'll put an extra attenuator into there. Okay, there we go. So that knocked down the signal a little bit. And so it looks like it is catching it at various points during its sweep. 390. So it looks like it is sweeping up. And again, that's with the sweep on. And so if I click this guy off, the signal goes away. Alright, stop it. Okay, so it looks like the sweep function is working over that range, and that's about how fast it's sweeping. Very cool. Actually, maybe I'll take a look at what's coming out of the M clock. I suspect that's so you can sync it up with another instrument, because sometimes you want to sync your signal generators to the fundamental clock. And let me just take a look at what's coming out of that. Okay. Okay, so I set up the output to the M clock, and I've set this one on the lower frequency range. I went back into mode over here, and it looks like it's got a bunch of different, it's probably like a square wave coming out of this thing. And looks like the lowest one is at 25 megahertz. And I believe, let's see, settings, we can change the clock. And reference clock. I don't know, can we change it to a different frequency? Can we change it to like 30? Enter. Okay. Doesn't seem like it changed the frequency here, though. Did it change it? Oh, maybe I gotta hit enter. Okay. Change the amplitude here. Maybe that's a reference clock input. Like I said, I don't know, because this thing comes with absolutely no directions, no instructions. So I guess we can go back to the main menu, so don't know how to make that work. Some other kind of PLL chips, maybe. Maybe that's so you can link it up with a phase lock loop. I'm not sure. Anyway, so there is some kind of signal coming out. It doesn't seem to change when I change the settings over here. I changed it to 30 and it did not change anything. I tried changing the amplitude too. I guess I'll change it back to 25 because I don't even know what that's doing. Maybe nothing. I changed the amplitude here, and that doesn't seem to be doing anything over here on the output. Okay, so anyway, some mystery option that I have no idea what it does. But this is the 6 GHz phase lock loop signal generator. Very cool. It puts out quite a bit of power, about 5 milliwatts or so. Okay. And anyway, I think that tests all the functionality of this guy. This is Dr. Janes, and thanks for watching.